This is the Earth Science Classroom. Welcome back to the channel. In this video we're looking at igneous petrology and looking in more detail on the textures of igneous rocks. Now in particular, this texture we're looking at is called porphyritic or porphyry, and it is a certain texture, and we'll get onto it in this video. So when discussing texture, the texture for an igneous rock is the outside surface, the appearance conditions, and it's based on the ratio of glassy outside conditions or material of that igneous rock versus the amount and size of the mineral crystals and crystallization and consolidation of those minerals in the rock. They're either visible or not visible. So if it's visible, we call it phaneritic. If it's not visible, it's fine grained, and we call it aphanetic. So the grains or the size of the minerals can affect and control the texture of that igneous rock. Now in terms of texture, this video is on porphyritic or porphyry texture, which comes from the Greek word meaning purple, but it's based on this Egyptian stone they used to admire. And in terms of geology or modern geology, it means that there is two distinct sizes or populations of crystal grains or sizes of crystals in the single rock, and the texture can identify or be identified as porphyritic based on these two sizes of crystals. So the two different phases or grain sizes, the smaller, more consistent, finer grained part of the igneous rock is called the ground mass or the matrix. And then the larger, more visible, more apparent crystal growth and the larger minerals you can see within the igneous rock. Like in this picture, you see those larger mineral growths, the quartz and the feldspars. They're called the phenocryst. And the phenocrysts can be divided into different sizes. So if they're really small or less than 0.5 millimeters in length or size, they can be called microphenocrysts. And they're between 1 and 5 millimeters, still kind of small but definitely visible. They can be called megaphenocrysts. So the size can change based on the amount of time that the crystal has to grow within the magma material. So this kind of texture, porphyritic or porphyry, is common in mostly extrusive rocks, but can be sometimes found in intrusive rocks. Now, the reason why it's mostly found in extrusive or volcanic igneous rocks is the way that these rocks form and the process of taking that magma from under the ground to on the surface and flowing through a volcanic eruption. So the two phases of mineral sizes and grains come from the formation and how the process occurs. So you have this magma chamber with magma material inside, and it's there for a certain time. Now, the temperature of the magma, the depth of the magma under the surface, and the time in which it stays magma and under the surface and how fast it cools, that's going to dictate the crystal growth, the size, the grains, and the level of size of phenocrysts you can get in the magma. So eventually, when this magma is going to erupt on to the surface through volcanic activity and eruptions, you get this already established amount of or ratio of large crystal growth of these phenocrysts in the magma as it erupts on the surface, and the other remaining magma or melt that has not yet consolidated or crystallized quickly cools down when it's exposed to the atmosphere or wherever under the ocean but on the surface, and cools down very quickly and doesn't have time to form these crystals and becomes literally like frozen liquid, like an obsidian kind of rock or a pitch stone. So this ground mass is formed with fine texture or aphanetic texture where you can't see the crystals, the visible crystals, because they don't have time to grow. But you also have the inclusion and the ratio of these larger phenocrysts that have developed whilst in the magma underground. So now this cooling rock, this extrusive cooling rock like a rhyolite or a trachyte, what we have here in this picture, you have the ground mass of these small fine material, and in between you have these large phenocrysts that are visible, and the alignment can show the flow of lava, or even the shape can tell you the type of crystals that you have that have grown, or the size or the time that the magma spent underground before it erupted on the surface. So porphyritic and porphyry is a very common texture in igneous rocks and can tell you a lot about the magma chamber, the magma itself, and the eruption, and how fast it cools down.